Welcome to The Explainer. Today, we are tackling a massive, complex challenge that literally almost every modern tech company is wrestling with right now. And that is, how do you actually adapt product workflows for artificial intelligence? Look, building AI products is a fundamentally different beast from building classic software. I mean, it's not even close. If you try to treat them the same, you aren't just slowing your team down, you are actively setting them up for failure. So we're going to dive deep into exactly how and why traditional methodologies just completely break down here, and what operational adaptations are absolutely necessary to ship AI features with both serious speed and uncompromising quality. All right, so here is our roadmap for the day. We're going to start with why traditional Agile breaks, then we'll compare Scrum versus Kanban for AI, and unpack 4 specific frameworks for AI work. After that, we'll cover 6 essential AI adaptations, dig into roles, backlogs, and what done actually means, and finally wrap up with some really common AI Agile failure modes. Let's get right into it. Section 1. Why traditional Agile breaks? To figure out the solution, we first have to fully wrap our heads around the paradigm shift. Listen to this quote for a second. The worst thing you can do with an AI team is impose traditional Agile sprints, where every story must ship at the end of the sprint. The fundamental issue at play here is empirical uncertainty. Unlike building a standard API endpoint where a senior engineer knows almost exactly how long the task is going to take, AI work is heavily experimental. An AI model might literally hit an absolute dead end after 3 solid weeks of training. If you try to impose rigid, date-driven sprints on top of that kind of deep uncertainty, you're invariably going to face one of 2 outcomes. You'll either miss your deadlines entirely, or even worse, you will panic and ship terrible quality models just to hit an arbitrary calendar date. And let me tell you, both of those outcomes will absolutely destroy your team's credibility. Think about building a traditional login page. It's deterministic, right? It's predictable, you know the architecture, you can estimate the time within a pretty reasonable margin, and frankly, shipping that feature with a minor visual bug is often totally acceptable because you can just patch it later without much fuss. Well, AI work is an entirely different reality. Imagine trying to train an AI to reliably understand human sarcasm. It is highly exploratory and empirically uncertain. You cannot just speed up model training by throwing 5 more engineers at the problem. It just doesn't work that way. And most crucially, AI work must be fiercely quality gated. Shipping a bad model doesn't just cause a minor visual glitch. It generates wildly incorrect or totally unpredictable outputs that result in a severe, immediate loss of user trust. And in the AI space, user trust is incredibly hard to win back once it's gone. Moving right along to Section 2, Scrum versus Kanban for AI. So, with the old assumptions broken, we clearly need a new methodology, one that keeps the core Agile principles of frequent iteration but adapts strictly to unpredictability. Now, Scrum and Kanban both offer some really unique advantages here. Scrum provides a time-boxed, predictable rhythm that's incredibly useful when you need cross-functional coordination, like, say, syncing up your front-end engineers and your design team for a major launch. Kanban, on the other hand, operates on a continuous flow and is tailor-made for bottleneck management. You're going to want to lean heavily on Kanban when your AI work is highly variable, or when you are simply sitting around waiting for massive models to finish training. In practice, the absolute highest-performing AI teams out there often use a hybrid system. They might use Scrum for their biweekly planning cadence and cross-functional syncing, while simultaneously managing the day-to-day, unpredictable model training tasks through a fluid Kanban board, just to prevent those bottlenecks. Section 3. 4 frameworks for AI work. Let's organize all this unpredictable work. There are essentially 4 distinct frameworks you can adopt, and it really depends on your specific team's structure. First up is model-focused Scrum. Sprints run 2 to 3 weeks, but here is the key difference. Instead of committing to shipped features, the team commits to reaching the next quality milestone. For example, maybe the goal is just reducing hallucination rates by 10%. Second is time-boxed exploration. This replaces sprints entirely with 4 to 8 week phases. Why so long? Because AI teams need a runway. You commit to exploring an approach and hitting specific exit criteria, which gives the team the necessary breathing room to actually experiment without the suffocating pressure of an artificial 2-week deadline. Third, we have parallel tracks. This is where feature teams run on standard 2-week sprints, while the model teams work asynchronously in the background. And finally, number 4, continuous integration with release gates. This one totally abandons time-based sprints entirely. The work flows continuously, and you only ship when a strict mathematical quality gate is actually met. So why does a giant like Microsoft Copilot use parallel tracks? Well, because it allows multiple massive teams to operate efficiently at the same time. Their model teams operate on 4-week exploration cycles, heavily optimizing for quality and accuracy. Meanwhile, the feature teams are building the UI and the APIs on standard 2-week sprints. But here is an absolute make-or-break product management lesson. Parallel tracks only succeed if synchronization points are explicitly enforced. Every 4 weeks, they have a hard integration gate where both teams sync up and formally commit to the API shape and the model quality. Without these explicit gates, the teams will just completely drift apart. You'll end up with a nightmare scenario where the UI team builds this elaborate interface for a predictive feature that the model team just realized is mathematically impossible to even build.
Now contrast that approach with Anthropic. They use continuous integration with release gates. They decouple shipping from calendar dates entirely. The work just happens continuously, and when a new AI capability hits their highly rigorous quality bar, it goes into a ready-to-ship queue. Sounds great, right? But pulling this off requires incredibly sophisticated infrastructure. You absolutely need rigorous feature flagging. When you abandon time-based sprints and ship continuously, you must have the ability to toggle features on and off dynamically. If a new model update starts behaving erratically in the wild, you need the superpower to instantly flip a switch and turn it off for 90% of your users rather than sitting around waiting for a frantic rollback sprint to happen.
Which brings us to Section 4, 6 Essential AI Adaptations. Whichever framework you ultimately select, there are some non-negotiable operational rules you absolutely must adopt. Number 1, quality gates override sprint dates. If a sprint ends and your model hits 78% accuracy when your agreed threshold was 80%, you do not ship it. Period. Number 2, estimation is complexity, not time. Trying to accurately guess how many hours an exploratory AI model will take is a total trap. Instead, teams should use t-shirt sizing, like small, medium, large, based purely on the complexity and uncertainty of the task, purposely avoiding false precision. Number 3, experiment and evaluation is legitimate sprint work. If your team spends 2 weeks and discovers that approach A is vastly superior to approach B, that is not research overhead. That is actual, hard product development work, and it must be celebrated as a sprint success. We're rolling into the next 3. Number 4, separate model and feature timelines. You must ruthlessly parallelize or explicitly integrate. Otherwise, your front-end engineers are just going to sit idle, twiddling their thumbs, waiting for models to finish training. Number 5, monitoring is a mandatory part of being done, which we'll expand on in just a second. And number 6, use outcome metrics, not output metrics. I'd argue this is the most important rule of the bunch. Imagine a team cheering because they closed 100 story points this sprint, but the AI's hallucination rate actually went up in production. In the AI world, that is a completely failed sprint. You have to track whether the model quality actually improved for the user, not just how many Jira tickets you managed to close out.
Section 5, roles, backlogs, and what done actually means.
So, a successful AI Agile team requires crystal clear cross-functional roles. Your product manager owns the overall outcomes and the strategic trade-offs. The data scientist or ML engineer owns the core modeling and the mathematical evaluations. The standard software engineer owns the product integration and the system reliability. And here is a role that gets dangerously overlooked all the time: the designer. In an AI team, the designer is absolutely critical for managing what we call trust queues. A trust queue might be an interface element that explicitly tells the user, hey, AI generated this, please double-check the sources. The designer is also heavily responsible for crafting the failure mode user experience, basically ensuring that when the AI inevitably hallucinates or gets confused, the user understands exactly why it happened and how to cleanly proceed without getting frustrated. Next up is the AI backlog. Notice just how much of this work is completely invisible to the end user. Yes, you have the standard user-facing features, but an AI backlog must meticulously track the invisible work. It has to include rigorous evaluation tasks, massive data labeling efforts, extensive safety reviews, and fallback logic engineering. If a product manager only prioritizes shiny new UI features and starves the team of time to do this invisible work, the model will inevitably degrade. It will silently start generating biased, broken, or unsafe outputs, fundamentally rotting the product from the inside out. And this brings us to a massive paradigm shift, redefining what done actually means. In traditional software, shipping the code to production pretty much means you are done. Well, in AI, done is a comprehensive quality and readiness state. It means shipping the code, yes, but it also strictly requires meeting the model quality thresholds, completing all evaluations, successfully handling the failure UX, and most importantly, committing to 4 weeks of daily post-launch production monitoring. Now, you might be wondering, why exactly 4 weeks? Because of model drift. Traditional code is static, but an AI model in production interacts with highly unpredictable, messy user data in the real world. It might perform perfectly in the lab and completely fall apart in week 3 of the wild. Redefining done to include this rigorous monitoring phase is what prevents silent degradation.
And finally, Section 6, Common AI Agile Failure Modes.
Picture a doomed AI project for a second. How did it get there? Usually, the team falls into a few incredibly predictable traps. It almost always starts with imposing traditional Scrum, forcing complex exploratory research into rigid 2-week boxes, which just instantly demoralizes the engineering team. That pressure inevitably leads to trap number 2, shipping to meet dates over quality, which destroys user trust the very second the bad model goes live. Then there's the trap of treating essential experiments as just annoying overhead, or missing explicit integration gates, causing the UI and model teams to drift completely out of sync. But perhaps the absolute most dangerous failure mode is ignoring the evaluation work. When you don't rigorously evaluate your data, you create a very dangerous false sense of progress. Everything looks bright green on the project management board, but the actual intelligence of the product is actively worsening for the end user.
So let's bring it back to you. The difference between an AI product that revolutionizes an industry and one that slowly destroys user trust lies entirely in these workflows. Take a hard look at your current team right now. Which of these 4 frameworks are you actually using? Are you accidentally forcing a square peg into a round hole? And more importantly, what is the minimal viable change required to implement the adaptation you need most urgently tomorrow morning? You've got the exact tools and frameworks to champion this transition now. Go make it happen.